request all of you to be very active for this session. Any questions and any doubt, please write it down, and all of you are welcome to post your queries on the chat board. So all of you, please feel free to put your doubts and queries on the chat board. We will be very happy to answer them in the end of the session. With this, without wasting much of your time, I would like to invite Mr. Mithun to take this webinar forward.
Good evening, everybody. I hope I'm audible. Abhijit, can you confirm if I'm audible?
Yes, Mr. Mithun, you're audible.
Thank you very much. Thanks a lot, participants, for joining this evening. We'll be talking about crime analytics. Since Abhijit has already introduced me, I will not reintroduce myself. I will get straight to the topic of crime analytics. Now, insofar as today's presentation is concerned, I have 5 main goals in this presentation. The first one being introduction to crime analytics. What exactly is crime analytics? What are the different facets of crime analytics? This is something which we'll be seeing. The second goal that I have is to talk about the types of crime analytics. The third goal which I'll be talking about is how do we sort of analyze crime data? What are the strategies? What are the tools? What are the tips? What are the tricks that we use to handle crime data? We'll be seeing this through what is known as fluid framework. I'll talk about it in greater detail when I come to the fluid framework. Thirdly, I've got a couple of exciting case studies which I had done. This case study gives us both a strategic as well as tactical insight about the world of crime. And fifthly, what are some of the key insights that we can use to address the problem of crime? So these are the 5 goals that I have. In case you have any questions, you can please feel free to address these questions in the chat. Let me make a move to the next slide. So types of crime analytics. Now, when we look at the types of crime analytics, there are multiple types of crimes that we can see in today's day and age. Even before talking about crime analytics, my own interest in crime analytics sort of began. if you're a police officer and you want a quick solution about what is the immediate action that I can take in the next week to control crime in my area, in my locality, let's say in Kurmangala or in Jayanagar or in Kanakpura, then you would be looking more of tactical crime analysis. So CIT, tactical crime analysis, strategic crime analysis. I move on to the fourth type of crime analysis, wherein we are talking about administrative crime analysis. Here the emphasis is more on what are the administrative needs of the police agency, the government, and its community. So this is what we are looking at, the four different types of crime analysis. I will do a deep dive into some of these during the case study. Now, what is the crime analytics pipeline? So there is a beginning as well as an end when we talk about data analysis. Now, this entire stream of crime analytics pipeline can be broken down into three areas. The first one is pre-crime analysis, second being runtime analysis, and the third one is post-crime analysis. Please take this as indicative and not exhaustive, because it's not possible for me to list out all the analysis that we do under each of these branches. Under pre-crime analysis, mainly we are looking at early warning signals that our analysis reveals, so that we can apprehend incidents like murder, we can apprehend incidents like larceny, theft, vehicle theft, and also prevent crimes. So particularly we are looking at predictive analytics here. We are also looking at social media data and such things. Prepare a heat list of those zones which are highly vulnerable to crime. This is what we do in the pre-crime analysis. Now, runtime analysis is the second branch of second step of crime analytics pipeline. Here, we are going to do an area-wise or a region-wise analysis of the risk factors. For example, in a particular area, if you see a lot of liquor stores, or if you see bars, clubs, if you see stadium, you can expect high incidence of crime and such things in those areas. Secondly, we also look at social media feeds and such things, which can be very, very helpful in specifically identifying areas or spots, localities wherein you could see agitation and other incidents of crime. All these things fall under what is known as runtime analysis. The last type of analysis in this pipeline is basically post-crime analysis. My second case study, which I'm going to talk about in a few moments from now, is mainly about post-crime analysis. What do we do in post-crime analysis? Mainly, we look at trends and patterns for various types of crime in different areas to support law enforcement agencies. Secondly, very, very important, we pull out the threats. We look at the lead identification, and once we are able to identify the leads that lead to the criminal, we will be able to understand his modus operandi of the crime. And once we are able to make a mapping between the modus operandi of the crime and the criminal's profile, we will be able to apprehend the criminal. The third one is basically identifying the links between the suspects and their involvement in crimes and criminal activity. It looks pretty scary because we have a lot of steps here, but there is a framework which is called as Fluid, which I'll talk about, which breaks this entire sequence of analysis into very simple, very user-friendly, and easy to use approach. I'll talk about Fluid in the coming slides. So this is about Project Fluid. I'll talk about what is Project Fluid and how we can use Project Fluid as a very, very effective as well as a very, very efficient approach to tackle the menace of crime. Now, when we speak about Fluid, this entire approach of Fluid is broken down into 6 different steps. And as you can see here, the first step is about collaborate, wherein we empathize with the end user. Here, the end user is actually the citizen, because not just the citizen, but also the police officer, because the police officer would need something very quick, something very easy to understand and implement, so that he can reduce the incidents of crime in his particular area. So identifying the stakeholders, eliciting the pain points, and empathizing with the end user becomes very, very important in the collaboration stage. The second stage is about the defining stage. Here we define what are our key performance indicators. What is it that we are after? I want my crime rate in a particular region to go down by 3%. Currently, it may be 10%. I want incidents of murder to go down by 7%. Let's say 3% or 4%, whatever be the number. We list it out in concrete numbers. so that it's very, very clear for everybody that this is the KPI that we are hunting. So listing out KPI as well as key analytical milestones also become a critical step in the define stage. Moving on to the third stage, which is collate. Now, this is very, very critical because there is a principle in data science which is called as GIGO, GIGO, garbage in, garbage out. If I have poor quality data, if I've got weak variables, obviously I'll not be able to come out with pinpointed insights. So what we do in the collate stage is basically we resort to a lot of variable transformation, we resort to feature engineering. From the existing data, we try to maximize and obtain, we try to pull out as many features as possible. And this particular collate stage is very, very important. And I'll speak about this in the first case study, wherein I have been able to sort of generate from one variable, we have generated around 12 different variables, and each of these 12 different variables are very, very important in predicting the next crime. So collate is the third stage. I'll move on to the fourth stage, which is build. Here we are talking about testing hypothesis. Is it possible that those areas wherein we see weak socioeconomic indicators are highly vulnerable to crime? This may be a hypothesis, but does the data corroborate this? Is it possible that there are certain pockets in Bangalore or Karnataka or in any part wherein we see high assaults on women? If we see a high or a peak in assaults of women in certain pockets, what are the reasons behind it? Now we can address all these questions through the power of EDA or exploratory data analysis. We construct dashboards, models, we build statistical models, and we go on improvising on this. So collaborate, define, collate, build. The third stage is basically the deployment stage, wherein whatever model that we build, we are going to implement in a real-time scenario, and we look for early warning signals so that the model can effectively capture incidents of crime. And finally, we look at the impact of our solution on the GDP. Remember, when we implement any solution, it has to be tracked in terms of how many lives have we been able to save, what is the expected saving that we have been able to make, what is the reduced budget that we've been able to incur because of this. So capitalize or monetize would be the last stage. So collaborate, define, collate, build, deploy, capitalize. These are the 6 stages in which any analytical journey would and should proceed. And we are going to see step by step as to how we have used each of these 6 stages in the case study that I'm going to talk about in a few moments from now. So the first case study is what I'm going to talk about now. Here we are going to talk about both strategically, what are the long-term objectives, as well as we are going to discuss from a tactical perspective, what are the immediate action points that we can take to reduce incidents of crime. Now, one question that might pop up in our mind is, why are we doing crime analytics, right? We can do attrition analysis, we can do a lot of other default analysis, fraud analysis, and bank and such things. Why are we doing crime analytics? First is because increased incidents of crime hinders the growth of a nation. Now, if there is a huge spike in incidents of crime in a particular period of time, then foreign direct investments and such things will suffer. Those nations, multinational companies and other industries who want to make an investment in a particular country will think twice before making an investment, because they know, they just get the feeling that because of high incidents of crime, a particular region or a district or a state or a country is very, very unsafe. So this has a big impact on foreign direct investment, and a revenue will go down. Thirdly, the international image of a country itself takes a big hit, and the worst case could be that we are attracting a lot of sanctions and such things from many countries whom we call as allies. So these are some of the larger goals that we are trying to address through the power of analytics and how we are going to use analysis in tackling crime. I'll make a move on to the next goal here. Here we are looking at data. At the end of the day, the data scientist is as good as the data that he has. What are the important data points that you can look at? You can look at emails, you can look at video footages, you can look at chat data, you can look at text files, you can look at CCTV files, you can look at GPS information and such things. As I said, as I was just giving the example of the DSP in Palakkad, he mainly looked at the CDR, the call detail records, as well as the tower detail records. And by looking at the pattern of communication and such things, they were able to apprehend the murder. So each crime has its own footprints, and by tracing these footprints, it could be through email communication, video footage, or any of these input points, we will be able to track the criminal. So these are the input points. Collaborate and define. Now here I'm talking about my first case study. In the first case study, what are the critical objectives that we are hunting? What are the main objectives that we are trying to answer? First objective that we are trying to answer is identify the major crimes. What are the major crimes in San Francisco that are committed? The second one would be what are the districts? Name the districts with the most number of incidents of crime. The third objective that we have for us is identify the specific business hours of the day wherein we see a peak in the crime rate. And the last of the objectives that we have is, can we identify the locations, specific locations wherein we can take actionable insights to reduce incidents of crime. So these are the objectives that we have. Now, what is the expected outcome? The expected outcome is pretty simple here. We want to monitor, we want to regulate the crime. We also want to pull out certain early warning signals. Rather than doing a post-mortem of crime, we want to be in a situation wherein we can prevent incidents of crime. Now, let me just introduce you to the data set, because analysis and such things come later. Even before we go into the realm of analysis, we want to understand as to what is the data set all about. Now, when we look at this particular data set, San Francisco was infamous for housing some of the world's most notorious criminals in the inescapable island of Alcatraz. We're talking about San Francisco, the different districts in San Francisco, and San Francisco was traditionally considered to be a hotspot in the United States of America as far as crime and incidents of crime is concerned. So this is the data set. Now, data set, what is the data set? Many of you may already be aware of what is the data set. You are using data set on a day-to-day basis. Data set is nothing but a fact table. It just has a set of facts and figures. Now, what is the data set that we had look like? It had the date when the crime was committed. You have certain time stamp. You can see here, 13th May 2015. We had around 15 years of data roughly. What is the category of crime? Like larceny, vehicle theft, you have other offenses, you have robbery, assault, you have non-criminal activities. We have studied close to 40 different crimes in this particular data set. Third one is they've given some description. Which day did the crime take place? For example, the first crime took place in Wednesday. As you scroll down, you'll see different days in which the crime was committed. What is the police district near which this particular crime was committed? There are 10 different police districts like Northern District, Park, Ingleside, Richmond, Central, Tenderloin, and such areas wherein these incidents of crime were committed. Finally, how did the police resolve this? Did they arrest it? Was there no resolution? Did they book the person? What was the action taken? What is the address? And lat long of the incident of crime is also given. Now, if you have GIS, perhaps you could put it in a BI map and you could just visualize this, but I'm not getting into it. I'm just looking at this particular data set. Data by itself is dead. It's just a fact table. This does not tell you much. Now, one of the first things that I was fascinated is when somebody gives a data set, the critical thing is, the one question that we can always ask is, does this data set tell me a story? Does it tell me certain insights which are otherwise not apparent to the naked eye, right? Now, if you are able to splice and dice the data set, then the data set sort of starts telling a story and you'll start seeing certain interesting insights that this data set produced. The insights, I'm just dividing into two areas. One is strategic insights. This will help bureaucrats, administrators in long-term decision making. So here the emphasis is on long-term planning. How many incidents of murder can happen in the next 5 years or 10 years? how many police officers do I need, what is the kind of training that I need to give to my police officers, and where do I recruit them, where do I deploy them. All these questions can be answered through strategic analysis. It's a very basic analysis through, we are in the third stage, which is building dashboards. Now, when you look at from 2014 onwards, the data, from 2004, my apologies, in the x-axis, I've just basically taken the years, and the y-axis, I've just taken the total number of incidents of crime. Now, from 2004 onwards, you see here, there is a decrease in incidents of crime until about 2007. From 2007, there is an increase. Again, there's a sharp decrease and further decreases. And post 2011, the incidents of crime start peaking. Now, at an overall level, you can expect this in number of incidents of crime to increase further and further. Let us dig further into this particular data. We are trying to answer one simple question. If you look back at the objectives, one of the questions that we had in the deck was, what are the major crimes in San Francisco, right? There are 40 different crimes, but as they say, you don't have to go after all the crimes. Majorly, what are the crimes that have been committed? So this particular slide talks about some of the important incidents of crime. Now, here you can see all the crimes that I'm talking about. Some of the important incidents of crime. The major crime that seems to be committed is larceny or theft. The second major incident of crime is other offenses. Thirdly, non-criminal offenses. Fourthly, assault. Fifth one, drugs and narcotic-related stuff are also committed here. Now, if you look at below the graph, you see certain other incidents of crime as well, like trespassing and such things, extortion. But here you don't see too many incidents of extortion and such things. As they say in data science, 80-20. 80% of the efforts can be directed towards curbing, reducing incidents of theft, other offenses, narcotics, non-criminal. You would have still brought down the incidents of crime in this particular region. So that is one insight that we can pick up from this particular slide. Nextly, what I'm showing you is a tree map. This tree map only supports the argument that we made in the earlier slide. The way we interpret this particular tree map would be to say, the larger the rectangle, more the number of incidents of crime. The smaller the rectangle, fewer the number of incidents of crime. So almost 50% of the area, almost 50% of the area is occupied by larceny and theft and other offenses. To some extent, you also have suspicious OCC activity, burglary, vandalism, and non-criminal activities. So these are some of the incidents of crime which are majorly being committed in San Francisco. Further, if you want to drill down and do a deep dive analysis about the district-wise distribution of crime, let us just see which are those districts which see high incidents of crime, which are those districts which see low incidents of crime. Now you can see different districts here in the x-axis like Northern, Park, Ingleside, Bayview, Richmond, Central, Taraval, Tenderloin, Mission, and Southern. Now what is really, really eye-catchy is that the Southern district in San Francisco tops the list, which means if I'm a police officer or if I'm an administrator, the top three areas which are a source of concern for me would be Southern District. I am also thinking that Mission area and Northern districts are the ones wherein you see high incidents of crime. So this is about the region-wise analysis. We are in the fourth step of fluid, where we are talking about dashboards and such things. Now, fifthly, what you're seeing here is nothing but in the x-axis, you see all the districts, and the y-axis, what you see is the incidents of crime. How do we interpret this graph? This is nothing but a heat map. Darker the red color, more the number of incidents. Lighter the red color, fewer the number of incidents. Now, what is eye-catchy here is mostly theft. I see a lot of red color cells here, which means that theft and such things are happening the most. And as you can see here, there are more than 40,000 incidents of theft, particularly happening in Southern District. Southern District also sees other offenses, non-criminal activities as well. Now, when it comes to theft, you see Northern area and Mission area also seeing a reasonably high number of incidents of theft and such things. So you may ask me this question as to why is this benefit, how is this beneficial? Now, your life and my life does not revolve around catching criminals, But if you are a police officer, if you are an administrator, you considering the fact that police officers have a paucity of resources, you have a shortage of time. By looking at this kind of data-driven insights, you can take a call saying that, okay, in Southern District, I see a lot of incidents of theft, and therefore I need to control theft. I need to focus on Southern District. I should also focus on Northern District and Mission area to cut down on incidents of theft. So that sort of simplifies our effort, and that also gives us concrete reasons behind our decisions. Making a move on. Now you can see here the different time points, like we have at dawn, morning, afternoon, evening, night, and late night. Now we have broken the data into different times of the day, and using each time points, we are studying at what time do we see a high number of incidents of crime. And it's pretty easy to decipher here. The red line here corresponds to theft, and most of the incidents of theft are happening in the evening time. In the morning, it picks up. In the dawn, you have fewer than 20,000 incidents, but by morning, it climbs up to 30,000 plus and hits its maximum of 60,000 by evening. So at evening, Southern District, if you just sort of connect the threads here, at evening, Southern District, particularly incidents of theft, if you can deploy police officers, we can see a lot of improvement. We can see a lot of reduction in the incidents of theft-related crimes. Now you also see a green-related green colored bar, and that green color bar corresponds to other offenses. If you read the legend here, it corresponds to other offenses, and the third line here corresponds to incidents of non-criminal activities. Again, most of these incidents, when it comes to non-criminal activities, majorly it is happening in the afternoon, and by the time it is evening or night, it sort of tapers off. So all these are part of dashboarding, and we can sort of take strategic decisions, take strategic calls based on our analysis. Now I've come to the end of one episode, which is basically the strategic part, wherein using this bar chart, heat map, using clustered bar chart and such things, we were able to see what are the long-term patterns, what are the long-term trends in analysis. But when you look at the tactical analysis, if you look at the very second slide which I presented, there is the strategic part as well as the tactical part. Now, if we have to get down to the brass tacks and look at specifically what time in the day do I see a peak as far as crime is concerned, and what time of the day do I see a reduction in crime? Which are those regions wherein you see high incidents of crime and such things? If we have to do tactical or immediate, if we want to see immediate results, what we need to do is we need to do tactical analysis. Now here, I'm going to show you a few graphs. Now you can see here, there are 4 different types of crime that I've pulled out. Now the first type of crime that you see here is arson. Now in a day, there are 24 hours, which I'm sort of plotting in the x-axis, and the number of incidents that I'm plotting would be along the y-axis. Now when you talk about arson, arson is a kind of crime wherein people set their own property on fire falsely, and then they demand insurance and such things. In the first world countries, basically arson related crime is very, very prominent. In India and such places, mostly we do not insure all the items. We insure perhaps home, we have vehicle insurance and such things. But arson and such things, from carpet to body parts, almost everything gets insured in first world countries, and many of them deliberately sort of put their property on fire and make exorbitant claims. So if you want to look at arson related crime, one of the key insights that I can pick up is that in the morning around 4:30 you see an increase of arson related crime, then it sort of reduces. Again in the late night around 10:30 and 11 you see again arson related incidents coming up. So in either the morning or late in the evening you see arson related crime. Now compare this particular profile with another set of data, which is disorderly conduct. Now, when you look at disorderly conduct, it is the same data. I'm not doing any advanced machine learning techniques here. I've not applied artificial intelligence and such things here. But the beauty behind Fluid is that it puts puts a lot of emphasis on creating dashboards. It wants you, it says not every problem is a machine learning problem, not every problem is a deep learning problem. We can pull out a lot of interesting insights purely by looking at dashboards. And the moment you slice and splice the data set, you can see here there are very, very crucial insights. Now, look at disorderly conduct. The profile itself is different here. Disorderly conduct you mainly see at 5:30 a.m. or 6 o'clock. So I do not know. I'm assuming this. Maybe there's a stadium, and since in US people are very, very crazy about soccer and such things, people may have had a nice party. You may see a lot of bars or pubs and restaurants. People may have had a lot of people. People may have come out of a stadium and they may be indulging in disorderly conduct. So those areas wherein you have high incidents, high number of pubs, restaurant, bars, and such things, this is the place wherein you can sort of focus on deploying your resources so that you can sort of reduce disorderly conduct. Now let's look at extortion. You see most of the extortion related incidents either at 12 o'clock, that is in the morning, or again at 1 p.m. So extortion is a different, it has a different profile completely. When it comes to drugs and narcotics, this has a completely different profile. It mostly peaks at 3 a.m. and it continues till evening, and then it slowly peters off. So you see 4 different incidents of crime. Now, as I said, at the cost of repetition, what does this tell me? This helps me identify what are the specific time points in the day wherein I see a peak crime. And given that there are peak incidents of crime, I can deploy my police officers, I can give them specialized training and ask them to sort of sort of watch specific areas and specific time points to reduce incidents of crime. On to another set of data. Here I'm looking at robbery, I'm looking at suicide, I'm also looking at gambling. Very, very simple incident. Now, you can see here when it comes to robbery, mostly late night is the time wherein robbery and incidents of robbery sort of peaks up. Now, compare this with gambling. It is almost in the afternoon, 12 p.m. is when you see incidents of gambling take place. And when it comes to suicide, you see majorly 2 peaks, either at 1 o'clock or you see at 8 p.m. wherein you see high incidents of suicide and such things taking place. So this is about time profile. I've not done anything in terms of machine learning so far, but simple graphs itself tells me a lot of things. Let me just make a move on to another set of data wherein we are talking about assault on women. When we talk about assault on women, majorly you see around 1 a.m. you see a huge incident spike in assault on women, and through the day, though there are incidents of crime, but you see this peak, it is touching almost 500 plus incidents at around 1 o'clock. Now, if you look at non-forcible incidents of crime on women, again, it is either 1 o'clock or at 11 o'clock, it tends to peak. So this is about the time profile of crime. Now, time profile of crime is good, but it is only incomplete information. What we are looking for here is we are looking for actionable intelligence. I repeat, we are looking for actionable insights. One is to look at the time, but one more question that we may ask ourselves is, in which specific region do you see these incidents of crime, so that I can deploy more police officers, I can deploy other law enforcement agencies so that I can reduce this. Now, just jog your memory back. If you look at arson, we saw that in the morning as well as in the evening, we saw incidents of arson shoot up. Now here, I'm talking about the different districts like Tenderloin, Tarawa, Southern District, so on and so forth. I have plotted the incidents of crime here. Now, out of all the districts, what you see here is Bayview is one district which tops the list. Now you know that out of all the districts, if I have to bring down arson-related crimes, I have to focus on Bayview. Not that other districts are free from this, but relatively they are lesser in other districts as compared to Bayview. Compare this profile with assault. Bayview is relatively free when it comes to assault-related crimes. Suddenly, what you see is Mission area and Tenderloin areas. These are two areas wherein the incidents of crime sort of shoot up as far as assault is concerned. So simple graphs, a simple horizontal bar chart is telling me when do I put my resources, where do I put my resources, what time do I put my resources. This is what I mean when I say actionable intelligence. Let us go move on to another set of data. Here I'm talking about forgery and counterfeiting. Almost all the districts see huge incidents of forgery and counterfeiting, but what tops the list is Southern. So if I have to bring down forgery, counterfeiting incidents, mainly I have to look at Southern areas because this is the one which tops the list. It's almost 2,500 incidents. Vandalism and such areas and such incidents are seen everywhere, but Southern area, Southern district tops the list when it comes to vandalism as well as counterfeiting. Disorderly conduct. Now, again, if you just go back and see disorderly conduct, we spoke that in the morning hours you see huge incidents of disorderly conduct. Now, where do I deploy my resources? This particular slide answers that question. Bayview is the one wherein you see huge number of incidents of disorderly conduct. So Bayview, you can also focus on Ingleside and to some extent southern areas, specifically in the morning hours of 5:30 and 6:30. You can focus on this particular crime. Now, how is this useful? I've already told you. Since the police officers work in shift, morning shift is different, evening shift is different, and night shift is different. You can basically you can optimize the resources appropriately so that we can tackle this kind of crime. Look at drugs and narcotics. Bayview has suddenly gone silent. Now you see Tenderloin. It sees almost 15,000, almost like 17,000 incidents of crime related to drugs and narcotics. Now, this is about time and location profile. Now, just sort of curiosity, what I've done is basically I've also looked at the day in which the crime has committed. We looked at time, we looked at location. Now, what we are looking at is in which of the days, is it on a Monday, is it on a weekend, you see a spike in incidents of crime. When it comes to assaults, clearly Saturday and Sunday, you see huge spike in incidents of crime. And when it comes to incidents of burglary, Friday is the day when you see huge spike in burglary-related crimes. When it comes to vehicle theft, again, it is Friday. Mostly on a weekend, you see vehicle theft and such things. Compare this with drugs and narcotic. Wednesday, the middle of the week, is when you see high incidents of drugs and narcotic. To just take you back here, Tenderloin. So Tenderloin tops the list. Now we see that Wednesday is the time when there are the huge incidents of crime in Tenderloin area about drugs and narcotics. So all this is simple analysis wherein I'm focusing on time, day, and such things, what we call as descriptive statistics, or we can also call this as exploratory data analysis. Now look at disorderly conduct. We saw that in Bayview you have high incidence of disorderly conduct, particularly in the daytime. The question is, which of the days, which of the 7 days do you see a high incidence of crime? Tuesday and Wednesday, you see a top, you see a peak in the incidence of disorderly conduct. Tuesday and Wednesday, I want most of the police officers in Bayview, 5:30 to 6 o'clock. I think that would bring down disorderly conduct to a large extent. So that is some of the recommendations that we can make from this particular graph. Similarly, Tuesday, again, you see spike in arson-related crime. Again, you can see Tuesday, not much of a difference in family offenses. Again, you see Tuesday, there is a peak. When it comes to forgery and counterfeiting, Monday, Tuesday, Wednesday, by and large, you see high incidence of forgery and counterfeiting, right? So since I've already interpreted this, I will not again interpret this. This goes to show how simple dashboards can reveal a lot of actionable insights. So I've come to, I've shown you time, location, and date. Now, in the data set, there are many incidents of crime which are unresolved. The police in San Francisco have not been able to find resolution for this. Now, particularly if you're a mayor or if you're a district administrator, you might want to see which are those crimes which are mostly unresolved. I see a stunning 90% of the incidents of crime under larceny and theft which are going unresolved. followed by burglary, arson, and robbery. These are the three areas. These are the three kinds of crime. Mostly they are unresolved crimes. Now you can see certain other incidents like drugs, disorderly conduct, and gambling. By and large, they have a higher resolution rate. Now, when you looked at this is the unresolved part. If I move on, you can see those cases which see high resolution. And this is a very interesting stack bar chart. You see multiple colors here, and the x-axis you have different types of crime that I have considered here. Majorly, what catches my eye here is the green colored portion, because the green colored portion you can see here are represent the unresolved cases. And as before, we can confidently say that cases related to burglary, arson, and fraud, as well as larceny, are not resolved by the San Francisco police. Now, I also see a ray of hope here, because when you talk about drugs and narcotics, the portion of green is less here, which means that more number of cases are resolved when it comes to drugs here, and the blue color here corresponds to arrested or booked here. So most of the drugs or narcotics related crime incidents are either arrested or booked. You see few bribery related cases also being arrested or booked. You see kidnapping and such things also see appreciable length of blue color, indicating that they are getting resolved. So in the first case study, what we have seen is basically time and location profile, and all this is basically part of what is called as bivariate analysis, wherein I focus just on two variables. Now, moving on, bivariate analysis is good, but that is more like a first aid. If I have to use a doctor's language, that is more like a first aid. If you have to take this to the next level and you want to do multivariate analysis, you have to do what is called as unsupervised learning techniques. You have to use unsupervised learning techniques. And those of you who are data scientists or who are working professionals would realize that this is nothing but an example of dendrogram. I will not explain this in detail, but I'll just talk about certain key insights of dendrogram. What we have been able to do here is classify the different zones of San Francisco as high risk areas, medium risk, and low risk. What we have seen is, what are the examples of high risk areas? Bayview, Ingleside, and Mission areas are the ones which are high risk areas. Now, when it comes to Central Park and Richmond district, they are constitute medium risk, and the last is low risk. An example of low risk area would be Tenderloin. Now, what are the typical profile of high risk areas? High number of incidents of assault, high incidents of arson. You also see reasonably high incidents of disorderly conduct and burglary related crime. You can see 21,800 odd cases, which is the highest when it comes to larceny and theft. So high risk areas like Bayview, Ingleside, and Mission need to be avoided for assault and such things. When you look at medium risk, that is Central Park and Richmond, most of the numbers are in between high risk and low risk. And I'll quickly jump to low risk. Low risk because if you can see the number of incidents of crime here, relatively they are lesser as compared to the first two brackets here. But there are certain crimes. For example, if you scroll down, you look at warrants. 7,300 cases, it is the highest. Similarly, if you can look at other incidents of crime, like okay, this is relatively lesser, but 833 disorderly conduct is again higher in Tenderloin. So this gives us an area-wise or a zone-wise risk profile of Bayview, Ingleside, and certain other important districts. Okay, now I've come to the end of case study 1, wherein we are talking about time, location, and day profile. We have also looked at a few unresolved cases, compared it with resolved cases. We looked at the risk profile. If you have any questions, you can please post these questions in the chat. At this point of time, I would like to also say that we have a lot of videos related to crime. We have a lot of videos related to cyber security. We have a lot of videos related to deep learning, artificial intelligence, and data science in our online in YouTube. I request you to take a look at our channel. I request you to subscribe and like our channel as well. If there are any questions, I'll be happy to take it. Otherwise, Abhijit, you can just tell me if there are any questions. I don't mind addressing some of these questions.
Yes. So one question that is there, Mr. Mithun. So we can definitely see that most of the decisions taken for crime are basically instinctive as well as experience oriented. So now you are saying that everything has to be data driven.
Yes.
So apart from this, what are the other benefits that organizations or stakeholders would get if they use analytics for crime?
Yes. So firstly, when you're talking about decisions, it takes two hands to clap. You need analytics as well as domain expertise. So this is what fluid approach strongly advocates. If you look at the very first stage wherein I'm talking about collaboration, I am saying that analytical approach, this is a hybrid approach wherein we have to support analytics. We have analytics, analytical solutions has to complement domain expertise and vice versa. That is, domain expertise also has to complement analytics. So both of them should go hand in hand, and only then we can do justice to this menace of crime. Secondly, your question as to what are the advantages, you can take real-time decisions, you can look at historical trends and patterns, and as they say in English, data does not lie, numbers don't lie. Because we are taking decisions based on historical records and such things, and not based on rules or empirical evidence alone, we are more likely to do justice to our resources. We are more likely to curb a lot of incidents of crime, because we are, whatever decisions that we take are backed up by solid data, solid research. So these are two or three solid reasons as to why I would advocate data driven decisions rather than just a rule based or experience based decision making. I hope that answers your question.
Yes. So what I have understood is mostly the experience part that an individual has gained over a period of time in administrative or in police. So they need not. They have to combine with analytics to execute analytical decision.
Exactly. So analytics is not an enemy of experience. You can use data-driven decisions to support your domain expertise to your experience, and you can see that's why we also speak about testing of hypothesis. Many of our hypotheses and such things about crime may be true or may not be true. Once we use data, once we get these insights, we can strengthen our claim. We can go to our top decision makers and say, this is what the data is saying, and therefore I need X amount of budget to be allocated to this particular crime, to me to have more trained specialist police officers. I want to have more dog squad and such things. I want to procure more arms and ammunition so that I can curb the menace of crime. So if you have data-driven backing, I think your claims will be respected more. That is my understanding.
Agree. Please go ahead. Please go ahead with the case study too.
Yes. So first case study we've just finished. Now I'm making a move on to the second case study. Now this is a very, very interesting case study. Now this case study is called as profiling Darknet sellers. I repeat, this case study is about profiling Darknet sellers. Now, if you recall, one of the in the types of analysis, I was just speaking about administrative case analysis, wherein we spoke about lead generation and such things. Case study 2 belongs to this area of crime analysis. Now, most of you would have heard of Darknet. Question is, what is a Darknet? To put it in simple layman's language, this is like internet for criminals, wherein this is like an illegal network which operates outside law. Now, these are websites from where you can order drugs, illegal arms, and malware. You can get hacking software. You can order the assassination of people. You can procure controlled substances. You can do kidnapping. You can steal credit cards of people, forge documents, unlicensed pharmaceuticals. You can also procure steroids, you can trigger cyber arms and such things. And this is not a joke. Just recently in West Bengal, there was a case wherein a few college students from engineering college, they had procured cocaine, and they were basically trying to sell it to other students in the other engineering college. So the Kolkata police basically addressed, arrested these people. So these are things which we see on a daily basis in one or the other part of the country. Now, we also saw sometime back a popular Bollywood actor son being arrested by NCB in connection with drugs. So this is the person. His name is David Skipper Everlink. This is the gentleman who wrote a Python code, and he was able to do web scraping of all the darknet related information, darknet related sites. Now, one of the problems that the law enforcement agency has is that if you pull down this particular site, very quickly it comes up with another name somewhere else. Now, here I've not focused on all the products. I've mainly focused on 1,500 cocaine related products. We'll see some of the analysis that I have done in the subsequent slides. Now, this is a generic slide wherein I'm saying as to why do we see a proliferation in terms of this darknet related crime. One is because it gives anonymity, and anybody, all that you need to have is basic internet facility. If you have internet facility, you can go to darknet site and pull out any of these banned substances. Primarily, you can see Tor or Onion network. These are the ones which are prominent for soliciting these drugs. Secondly, you also see heavy usage of bitcoins or virtual currencies. This is the second reason as to why you see a proliferation of drug-related crimes. Thirdly, escrow. What's the escrow? This is a hidden account from which money can be transferred, and there is no way of finding out the details of the consumer or the person benefiting out of it. Fourthly, vendor feedback system. This is almost like an Amazon-like system wherein you can sort of go there and put up your products, and there you can see people have also given rating, just as you give a rating for a sari or any laptop and such stuff. So all these four reasons, anonymity, virtual currencies, escrow, and escrow account and vendor feedback system, have triggered a big network of crime of darknet users and sellers. So I'm just showing you a snapshot as to how this looks. This is just a snapshot. You can see the products that they are selling here. You can see like cocaine. What is the price? You can see DE to WW. DE is Deutsch, which means Germany. So the vendor is selling from Germany to worldwide. Now here again, you can see the vendor selling from Germany to European Union or Germany, and you can also see the Bitcoin price also being displayed. So all that you need to do is basically click on a particular item, and whether a person is shipping from which place to which other place. Escrow account is what you need to sort of supply here. The vendors who do the trafficking will be displayed. So this has become so simple that most of the younger generation is basically getting attracted to this. Now, somewhere I was just reading a report which says that the third generation of warfare will not be based on atom bombs and hydrogen bombs and nuclear missiles. It will be based on all these illicit substances, banned substances. You target youth and you can just spoil the youth of a particular nation. So this has become a big menace. So let me just explain this in detail in the subsequent slides. Now, what are some of the details that we had? We had around 1,400 products. This particular category is called as the Dream Merchants Cocaine category. Dream Merchants website. This data was obtained through web scraping, as I told you, on July 2017. We had the product from which place to which place this is being shipped. This is quantity in grams that is being shipped. What is the quality, Bitcoin prices, vendor details, and such details are given. So just a snapshot here. You can see the grams, and this is real-time data set. So this is not a figment of my imagination that you're seeing here. You can see some of the vendor names. Of course, these are all alias names like Mr. Molly. You can see Old Amsterdam, Smooth Criminal, Cocaine UK. What is the cost of pure gram and what is the cost for impure gram? Whether or not he has an escrow account. What is the quality also has been given on a scale of 1 to 100. If the number is close to 100, means high. What is the grams that are being used? That is given. Successful transactions is being given. Where is he shipping from? NL is Netherlands, FR is France, GB is Great Britain. Where is he shipping to? This piece of information is also given to us. Drug trafficking analysis. So let me just use the fluid technology again to uncover some of the insights here. Now, this is a simple histogram here. It just says that on an average, the price of cocaine is around $90 in USD. Further, if you want to see which are those nations wherein you can expect high cost for cocaine, you can see here, this is a tree map. Primarily what you see is Australia, Switzerland, Sweden and France. But majorly if you are soliciting cocaine from Australia, or if you're supplying to Australia, Australia tops the list in terms of it being expensive. So some of the other nations like USA, Brazil are relatively inexpensive. So I've also sort of plotted a bar chart here. You can see Australia, it is right at the top, which means that the most expensive cocaine is coming from Australia. The least expensive is coming from China. Further, if you look at the traffic, the drug traffic analysis, Netherlands to European Union, this is the area, this is the channel wherein you see the highest amount of drug trafficking. Netherlands, I don't know, it could be because you get a lot of free cocaine and such things, relatively inexpensive cocaine in Netherlands. So the highest amount of cocaine transaction that is done from Netherlands to European Union. Lowest is from Netherlands to worldwide. Now, this is a very interesting chart. So here, what I'm talking about is the source, and in the rows, the different source, the different countries are given. You have Australia, you have Belgium, so on and so forth. You also see the different destinations to which they are shipping drugs. Now, most of the cells here are blank, indicating that the vendors are very, very careful and they're very selective. They don't ship to all the places, but you also see a high shipping rate from Australia to Australia, or Australia to New Zealand. The green colored cells indicate high shipping rate. Here also, again, you see Great Britain, corresponding to Great Britain and WW. When you're shipping from Great Britain to European Union, or again to Great Britain, you see high price. So this is the price. Now, one very curious thing here is that when it comes to USA, by and large, most of the cells are blank. This is because in United States of America and Australia, I'm given to understand that there are very, very strict laws. And if you get caught in drug trafficking and such things, it could entail very, very harsh punishment. And therefore, most of these vendors are not supplying to US. Locally, yes, they may do it, but internationally, they may not import as well as export into places like US. Now, again, this is a heat map. Now, I'd like to draw your attention to the profile of price of cocaine shipped from Great Britain to European Union. What you see is highest quality of drugs is solicited, is delivered to European Union, because you can see the quality is 93.68, which is the highest. And it is very, very expensive, because in this entire column, you can see the 0.05, which means it is very, very expensive. And also, mostly they're demanding pure cocaine. The number of transactions, on the other hand, is less. So from Great Britain to European Union, expensive top-class drugs. On the other hand, Germany to worldwide, you see more number of transactions. However, inexpensive drugs and the Bitcoin prices also is less. So low-end drugs basically go to Germany and worldwide. So you get some kind of a perspective about what is the source as well as the destination of shipment of these drugs through simple cross-tabulation and such things. Now, though we had many vendors, I have just focused on 20 vendors here. This is part of the fluid wherein we are just doing a filtering. You can see some of these nice names like Mr. Molly or Sky High. You can just imagine what kind of sky and what kind of high. You can also see the best chemist, right? So these are some of the names of the vendors who are doing the transactions. Now, when it comes to vendor analysis, let me just do a deep dive of this vendor analysis. Now, you can see in the x-axis, I've just got all the vendors, and you can see a box plot corresponding to each of these vendors. I would like to draw your attention to the best chemist. For the purpose of brevity, we can just focus on the best chemist and the go fast team. Now, you can look at the median here. The median is the highest for best chemist. So when you look at the best chemist, this particular vendor, when he is selling drugs, his product is the most expensive. Also, please look at the size of the whiskers. It is quite high, which means that there is more variation in his price. There is more price volatility as far as the best chemist is concerned. So you just understand some kind of a profile about the best chemist. What he's doing is highest price as well as high price volatility. Now compare this profile with Go Fast, almost low price, and the size of the whiskers in the box also is less, indicating that there is less price volatility as far as Go Fast team is concerned. So here we are doing a comparative study of the cost of the different suppliers. There. Look at the best chemist. Where is he shipping from? You can see the line here. He is mostly shipping from Great Britain. Mostly he's shipping from Great Britain. Let me just look at the next slide. This slide answers where is he shipping to. Mostly he is again shipping to. If you just look at this, he's shipping to worldwide and European Union. So this is the profile of best chemist. When you look at Go Fasting, you can see a orange line here, which means that he is operating from Germany. Where is he operating to? He is operating again to Germany. So you understand what is the trafficking area as far as best chemist and Go Fast team is concerned. Go Fast team is mainly operating from Germany to Germany. The best chemist is operating from Netherlands to other areas. Further, this is a simple summary chart. You can just compare the numbers between Go Fast team and best chemist. Highest number of transaction corresponds to Go Fast team. Somehow the numbers are not as high in the case of best chemist. So we are looking at different parameters like the grams, quality, cost per gram, and successful transactions. Now, when it comes to best chemist, he's almost like the Ferrari or the Van Hussein in the world of drugs. Because if you look at his profile, he sells very limited quantity, highest price. The quality is also the highest, high-end supplier, and top class 93% purity, highest price as well as selective customers. Boutique vendor on invitation only. Now, if you compare this with Go Fast team, now what you see is he's more like the supermarket or the big bazaar. He ships in moderate quantities. He ships in large quantities. The price is the moderate, cost is the cheapest. He's the highest seller. That is some of the inferences that we can draw when we compare the profile between Go Fast team and the best chemist. Moving on, this is just a simple heat map which tells us about the relationship between the cost and the quantity. Deeper, darker the blue color, stronger the positive relationship, which means that price and quantity have a positive relationship. Finally, when we have to look at the profile of the vendor, we can just use what is a machine learning technique which is called as decision tree. This is slightly complicated to read the slide from here. So I will just directly talk about the profile. We have already seen the profile in terms of what is the profile of the best chemist as well as Go Fast team. We have said that best chemist, his top class, 93% pure, highest price as well as selective customers. When it comes to Go Fast team, he's mostly selling cocaine, which is slightly on the cheaper side. The quantities are also on the higher side. Price is moderate. So this is what I had for analysis. Do you have anything, because I've come to the end of the second case study, if you have any questions lined up for me, please feel free to ask.
So one question that one of our participants had asked is, how comfortable will be the government or authorizing bodies to share data publicly on this, for analytics? So how do we deal with this so many data? So is there any framework or how do we approach it?
Most data analysis, when we say, if you approach the government agencies and if you give them the assurance about the confidentiality of the data and about data security and such things, they will be definitely they will respond favorably to data and giving data sets and such things. And secondly, what is the second question that you asked, Abhijit? One is about the data and how comfortable they are. Second one is
there any framework or any process to approach this data issue?
When I talk about the fluid framework, this fluid framework itself is a approach which talks about analyzing how you can get the data, process the data, do your cleaning, identify what are your KPIs, and then analyze the data, give back the insights, and then also look at how we can sort of implement it in a real-time scenario. So fluid framework itself is a tested framework which can be used in any government agency or in any non-government agency to operationalize the entire process of analysis.
Right.
Yes.
So I think we are coming to the end of this session, and
right.
I would like to thank Mr. Mithun for taking us to such a wonderful presentation on crime analytics. I'm sure those who have attended this session, it will help them to think in the similar direction and help them to decide or implement analytics at their level. And to take this presentation further, Dr. Shinu, Program Director for REVA Academy for Corporate Excellence, will take us through the program details that is offered. I'd like to invite Dr. Shinu.
Am I audible?
Yes, please go ahead.
Thank you, Mithun, for a wonderful revelation of how to look at crime data and analyze, as well as help the enforcing agencies to hoping that because we know that a lot of enforcing agencies are also looking at this presentation, and many are attending this session. We are thankful that they find their time to learn how to look at crime data. Thank you so much, Mithun, for passionately presenting the whole 2 case studies. Just to give a small glimpse of what we do here at REVA University, which is a beautiful university located at North Bangalore, India. We have an entity called REVA Academy for Corporate Excellence, where we teach, we practice, we consult, we implement analytics across domains. So we have been in certain master's programs, but we also implement. So if you are looking at some of these real applications of crime data and looking at developing either a dashboard or predictive models, or developing an analytics set of projects to look at how to reduce the crime rates in your area, and if you are an enforcement agencies, we hope that you can connect with us, and then we could look at working collaboratively. RACE has been fortunate enough to work with 50 plus industry mentors who have been implementing large scale AI projects across. And a lot of our content is available in our YouTube channel. Our YouTube channel, please search it as RACE REVA. You could get to see a series of presentations as well as webinars like these, where you could get immense amount of knowledge in AI, analytics, cybersecurity, and other emerging technologies. Some of the programs that which we run for working professionals are displayed here. A few of the focus areas are, we have an MBA in business analytics, which is one of the top ranked programs. And here we are, the way that Mithun has explained crime analytics, we would look at multi-domain, interdisciplinary analytics applications where we would move an individual contributor to enterprise leaders with the power of analytics. And those who are looking at getting a MBA, real MBA degree, where we solve real business problems, please do look at this program. We also have an MTech MS Artificial Intelligence program. Again, one of full stack AI development skills is what we focus on there. We also have an MTech Cybersecurity, very, very prominent program from our portfolio, flagship program, which encompasses the entire cybersecurity landscape and help you develop resilient organizations. You can see the kind of partnerships also we have. We also are launching cloud architecture and cybersecurity, another master's program, and a program on software product development. So do look at some of the master's program or diploma programs or customized programs for your teams if you are looking at upskilling and ensuring that you are on top of digital transformation which is happening now. Again, look at MBA Business Analytics and Artificial Intelligence. And thank you so much for staying back patiently and listening to this webinar. We do hope that you connect with us directly, where we could help you. If you are a team leader, please do look at our program for your team. If you yourself are looking at creating a customized program or implementing certain projects in these areas, do connect with us. We would be happy to help you in collaboratively. Thank you so much. Thank you so much for all of you to staying back, and do connect with us later as well. Abhijit, over to you.
Thank you, everyone. Good night.
Thank you.